Hi, all right. Another update for today, and then I think we got to go and do some work. Yeah. This one, I feel like, so it's still a preprint, it's still on bioRxiv. I feel like this could be a quite important paper down the road. But of course, it's still got to get through peer review. Yeah. And I don't know, maybe they'll see something I'm not seeing, but what I'm seeing is pretty darn good. Yeah. Yeah. So here we go. The title of the paper is Structures of Human Antibodies Bound to SARS-CoV-2 Spike Reveal Common Epitopes and Recurrent Features of Antibodies. Yeah, okay. So what they're doing in this paper is they're just leveraging all the things that other people have learned in order to better understand antibodies and how they can stop the virus. Yeah, because they seem to be important. They're probably not the only thing. Don't ever get this antibody, blinders, uh, because there are other equally important parts of the immune system that are just a little tougher to analyze. For example, killer T cells or cytotoxic T lymphocytes, if you're feeling fancy. These are probably also very important from the data that we have as a part of the solution. So it's not all about antibodies. Yeah, at least you won't hear me say that. But yeah, these are all questions that good immunologists are better off at discussing than I am. So, what does this paper show? Well, what they're doing is they're taking the spike and just boom, putting it down. And they're taking a variety of antibodies, just taking antibodies from a person, chopping off, so you can divide an antibody with a little protein cutting enzyme into two halves. So remember, it's kind of Y-shaped, and so you can basically cut off the two little arms of the Y. Those are called the FAB, the antigen binding fragment, or fragment, comma, antigen binding. And then the bottom is called the FC, that is the constant fragment. And so the FC is going to be the same on all of them. The FAB is going to have the parts that are different on every antibody. And what they're doing is just taking those little FABs, because they're small and easier to work with, and putting them with the spike, and then putting them on an electron microscope. And since we already know the structure of the spike, and since FABs are always pretty much the same structure, they just differ a little bit in what amino acids are there and what they can stick to, but they're all kind of the same shape. All you have to do is look for where is the FAB antibody, if you like, sized blob that's stuck to the spike-sized blob, and then bam, you have a super low resolution but kind of useful map of where antibodies are binding and what antibodies are doing. And so they look at a bunch of things in here. They find that, for example, remember there are the three receptor binding domains that actually reach out and grab onto the cell. Remember, two are normally locked down, one's normally in the up position, that dumb little dance I've been doing for I don't know how many weeks now. And not surprisingly, there are a lot of neutralizing antibodies, the really good ones that can stop the virus, that are binding to the up position one, and they're just boom, hitting parts on that. And we know they're binding to the up position because, one, that's what we can see on there, but also because the thing that they're binding is normally tucked away. When the antibody is down, this little face right here where the antibody would bind is actually buried against another part of the protein called the N-terminal domain. But when it gets its turn to pop up, then bam, 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 yeah, antibodies are going to try to grab it, and if they grab it before the virus is able to grab onto one of your cells, then yeah, you just won that battle, and keep on fighting. Yeah. So they've got those, but the other really interesting one, they've got some that bind to the N-terminal domain, and those bind to a spot that's not too far away from the from amino acid 49. And so it's probably going to be an antibody like that that is the cause of the changes that they're seeing in Mexico with antibody 40 with amino acid 49 changing. Yeah, but that aside, yeah. The other interesting thing they show is that, remember, antibodies are not just this one little antigen binding fragment that floats around and sticks to stuff. An antibody's got two of those because it's a Y-shaped thing with two of these little grabbers on the end of it. And so the question's always been, well, all right, we know that antibodies can stick to the protein, and we know this because that's the easiest way to do the test. You make pure spike protein, you put it down. with pure antibodies, and you see where the antibodies stick. And so they're not in the normal configuration, because normally you have a virus. And yeah, on the outside of the virus, you have your spikes, and your spikes are going to be about 15 nanometers apart. And the antibody is just big enough that it can reach out and potentially grab 2 of these. And so they've done some modeling, and sure enough, some of those antibodies that are binding to the top of the spike do appear to the things they're binding are organized in such a way that if you had 2 adjacent spikes, yeah, you could potentially bind to both of them. And this is a different mechanism by which an antibody can work. So you can work by blocking the thing that's sticking up. That's the most obvious, and that's most of what they found. But you can also work by locking multiple spikes together, either on the part that sticks up or on the part that kind of locks those down. And by tying them together, you're just like tangling them up. It's like tying a bully's shoelaces together and watching them trip and fall. Yeah, kind of mean. Yeah, we shouldn't be doing that, right? Yeah, but against coronavirus, who cares? Yeah, beat him up. So yeah, that's the idea. Can antibodies tangle up more than one spike at a time, and is that a viable way to fight the virus? Quite possibly, according to this paper and according to what they found. So I feel like this is going to be important going forward. We've got already several ways to neutralize, and why the heck not add one more, right? Yeah. Another thing that the immune system can do to shut down the virus is always going to be okay by me. Yeah. Thanks very much. This was our Dr. Ben update.